Hydrogen fuel represents one of humanity's most promising pathways toward cleaner transportation, energy independence, and long-term sustainability. Unlike oil and natural gas, finite fossil fuels formed over millions of years, hydrogen is the most abundant element in the universe and can be produced from water, biomass, industrial byproducts, and renewable electricity. For over a century, society has relied heavily on petroleum and natural gas to power vehicles, industries, and electrical grids. While these fuels enabled modern civilization, they also introduced major challenges: air pollution, greenhouse gas emissions, geopolitical dependence on fossil fuel reserves, economic instability from fuel price fluctuations, environmental damage from extraction and transport. Hydrogen offers a fundamentally different energy model. What is hydrogen fuel? Hydrogen is not an energy source in the same way oil or coal are. It is an energy carrier. Much like electricity, hydrogen stores and transports energy that can later be converted into usable power. When hydrogen is used as fuel, the primary byproduct is water vapor rather than carbon dioxide. Hydrogen can power systems in two major ways. 1. Hydrogen internal combustion engines, H2ICE. 2. Hydrogen fuel cells. Both technologies aim to reduce or eliminate dependence on traditional fossil fuels, but they operate very differently. On hydrogen and internal combustion engines. Hydrogen internal combustion engines work similarly to gasoline engines. Instead of burning gasoline vapor mixed with air, the engine burns hydrogen gas. How it works: 1. Hydrogen is stored in pressurized tanks. 2. Hydrogen is injected into the engine cylinders. 3. The hydrogen mixes with air. 4. A spark plug ignites the mixture. 5. Combustion pushes the piston downward. 6. Mechanical energy powers the vehicle. The concept is familiar because it builds upon existing engine technology developed over generations. Advantages: uses existing engine knowledge. Manufacturers can adapt many current engine designs and manufacturing processes. Fast refueling: hydrogen refueling can take only a few minutes, similar to gasoline. Lower carbon emissions. When properly designed, hydrogen engines produce little to no carbon dioxide. Heavy-duty potential hydrogen combustion engines may be especially useful for trucks, construction equipment, agricultural machinery, marine engines. Backup power systems challenges nitrogen oxides, NOx. Although hydrogen combustion produces no CO2 directly, high-temperature combustion can still create NOx emissions unless carefully controlled. Storage complexity. Hydrogen has low energy density by volume, requiring high-pressure tanks, cryogenic systems, advanced safety engineering. Efficiency. Hydrogen combustion engines are generally less efficient than hydrogen fuel cells. Hydrogen fuel cells. Fuel cells generate electricity directly through an electrochemical reaction rather than combustion. This is one of the most exciting areas of clean transportation technology. How fuel cells work. A fuel cell combines hydrogen-oxygen from the air inside the fuel cell. 1. Hydrogen enters the anode side. 2. The hydrogen molecules split into protons and electrons. 3. Electrons flow through an external circuit, creating electricity. 4. Protons pass through a membrane. 5. Oxygen combines with the protons and electrons. 6. Water and heat are produced. The result: electricity, heat, water vapor. No combustion occurs. Benefits of fuel cells. High efficiency: fuel cells are significantly more efficient than combustion engines. Zero tailpipe carbon emissions. The main byproduct is water. Quiet operation. Fuel cells produce very little noise or vibration. Long-range hydrogen vehicles can often achieve longer ranges than battery electric vehicles while refueling quickly. Grid and backup applications: fuel cells can also power buildings, hospitals, data centers, remote infrastructure, portable generators. Types of hydrogen production. Not all hydrogen is equally clean. The environmental benefit depends heavily on how it is produced. Gray hydrogen produced from natural gas without carbon capture. Cheapest today, still emits CO2. Most common current method, Blue hydrogen produced from natural gas with carbon capture systems. Lower emissions than gray hydrogen. Transitional solution. Green hydrogen produced by electrolysis using renewable electricity. 2. H2O yields 2. H2 plus O2. This process splits water into hydrogen and oxygen using electricity from solar wind. Hydroelectric nuclear power. Green hydrogen is widely considered the long-term goal for a sustainable hydrogen economy. Why hydrogen matters. Hydrogen could help solve several global challenges simultaneously. Energy independence countries without major oil reserves could produce hydrogen domestically using renewable energy. Cleaner transportation. Hydrogen may be especially valuable for sectors difficult to electrify using batteries alone. Aviation shipping, heavy freight, industrial equipment, long-distance transportation, renewable energy storage. Hydrogen can store excess solar and wind energy for later use. This helps address one of renewable energy's biggest challenges. Intermittency. Industrial decarbonization. Hydrogen can replace coal and natural gas in steel production, chemical manufacturing, fertilizer production, high-temperature industrial heating. The challenges ahead. Hydrogen is promising, but large-scale adoption still faces obstacles. Infrastructure. Hydrogen fueling stations remain limited in many regions. Production costs. Green hydrogen is currently more expensive than fossil fuels in most markets. Storage and transport. Hydrogen molecules are extremely small and difficult to contain efficiently. Energy efficiency chain. Converting electricity to hydrogen to transport to reconversion can lose energy compared to direct battery usage in some applications. A balanced future. The future of energy will likely not rely on a single solution. Instead, the global transition may involve battery electric systems, hydrogen fuel cells, hydrogen combustion engines, synthetic fuels, renewable electricity, advanced nuclear energy, smarter electrical grids. Hydrogen's greatest strength may be its versatility. It can act as fuel, energy storage, industrial feedstock, grid stabilizer, transportation medium. Conclusion. Breaking free from dependency on oil and natural gas will require technological innovation, infrastructure investment, and long-term global cooperation. Hydrogen fuel, whether used in combustion engines or fuel cells, offers a compelling path toward cleaner transportation and energy resilience. While challenges remain, hydrogen has the potential to become a cornerstone of a future energy economy that is cleaner, more decentralized, more sustainable, less geopolitically dependent on fossil fuel reserves. The transition will not happen overnight, but hydrogen may play a major role in helping humanity move from a carbon-intensive industrial age toward a more balanced and renewable energy future.